and welcome to another ContinuousX podcast where we try to solve for X in the SDLC equation. In fact, welcome to the brand new season of ContinuousX. I'm your host, Mike Fitzurka, and today we have a guest lined up that I've been dying to talk to him, Arthur Hicken. He's the Chief Evangelist at Parasoft. And welcome, Arthur. It's great to have you on.
Hey, welcome. I'm glad that you've had me on today, and I'm looking forward to having an interesting conversation, Michael.
Oh, thanks. Great. So here at the ContinuousX podcast, we like all things continuous. So I personally believe that if a job's worth doing, it's worth automating. And if it's worth automating, then it's worth running that automation continuously to get the best out of it. So today we're going to discuss a topic that I don't hear a lot about, but which is kind of a shame. It's continuous quality. I've worked as a developer in the days when I'm dating myself here, but we worked in the days when we had a quality assurance program and a complete department. And I will be the first to admit that we abused them quite heavily and got them up to the last minute to just squeeze and admit that it's good. And so we can launch. And I do credit agile practices and everything that happened afterwards to automate testing, to get that testing done in the forefront. But I sometimes wonder if the overall goal of continuous quality or quality got lost from the continuous testing. So I know at Parasoft, you guys are big proponents of both testing and quality. So I was hoping that we could start this episode today by talking some best practices for our audience to implement just beyond continuous testing, but moving into continuous quality.
It's a pretty good thing, and our customers tend to skew toward places where quality is really, really critical. Planes, trains, and automobiles, as well as things like banks and fintech and things like that, where mistakes tend to be costly or even catastrophic. So being able to not just test, but know that the thing is good, right? It's well built and good and will behave properly under good circumstances, but also behave properly under the worst of circumstances, sure. Whether it's security, load, etc. It is very, very important to people. And as we moved into the continuous world, it became that question of, well, how much of this can I move? I remember, and like you, I go way back, going to customers where they had an automated process that at one point involved somebody like sticking a flash drive into a computer, copying a file to it, and moving it to another machine. We used to call that sneakernet back in the day because it was a floppy, right? But it wasn't a floppy. It was very modern. It was a USB, but they were moving it. And I was like, you can't automate this. This is not right. And over time, as you try to automate things, you find that you have to view any press of a button, right? Any click on the screen, any acknowledgement of software is something that will impede your automation strategy. So, thinking hard about how can I make sure that the human isn't doing something that they really don't need to do. And the other is, it's fundamentally a maturity game with continuous. Right? I've had a nickel for every time someone said, well, what's the tool I need to do continuous quality, right? Where's the tool? And the answer is that the more mature your organization is, the sooner you can get to continuous. If you don't have automated tests, if it's all manual tests, you're just out of luck. You're a long way from the world, and start with that. If you have automated tests, but you spend too much time in QA, right? Too much time testing, failing, fixing, then you have to start moving back to maybe more unit testing. And fundamentally, you end up ultimately at having a good static analysis program and a good requirements program, a really mature practice. We have to know what we're building, and then we have to be able to continuously assess whether it's doing what we wanted it to do and whether it's behaving properly under the conditions that we talked about. So, yeah, there's a lot to that. And people typically start at the right-hand side of the machine, at the tail of the machine, at the output, but you kind of need to start at the other end, right? Start producing better software.
Yeah, and I agree. It's all about that striking that balance, and it's about building on itself. You can't anyone who life is pain, and anyone who tells you otherwise is selling something. You've got to start. You've got to that's Princess Bride quote. You got to start where you're at, and you've got to get the if you don't have tests to begin with, you've got to get there, but um, before you can get anywhere else. But what's the what would you call maybe the graduation point? When do you become tests are good? But now let's look at quality, or what's clearly the difference?
Well, yeah, see, in a perfect world, right, in an ideal state, and we were starting new tomorrow, we would have a really good set of requirements. We would be able to associate our code with requirements because this tells us two things. One is it tells us that we haven't really implemented a requirement yet, so it's not going to work. Or it tells us that we have a bunch of code unassociated with requirements, which means there's something else wrong, right? It might be that our requirements are bad. It might be that we're adding lots of features. We got an internal developer-oriented feature creep, for example, or even a product management team feature creep. So it's important to be able to do that. It's important to be able to ultimately, when I have a test, at a simplest level, I want a test to tell me a couple of things. If the test passes, I want to be confident that a particular piece of functionality will work every time. And I want to know what that is. If a test fails, I want to know that a piece of functionality is broken, and hopefully where the root problem is, not
Right.
spending hours or days chasing something. So that's really what you want to be able to do, is know that when a test passes, it has a meaning, and when it fails, it has a meaning. And this sounds so simple, but people often fail at having a test that has meaning when it fails. They're used to a certain noise level. It's like when we spell check, right? And we're in a funny industry and we have funny words that we use. And sometimes you don't want to bother to train your dictionary on all these stupid words, people's names, and specific practices and tools.
Right.
But then when you're spell checking, you're sifting through error messages, trying to make determinations, and you miss things, right? Plus, it's a very manual human process. So, yeah, I want clean test suites. I want meaningful test suites. I don't want tests that have been failing every day for 5 years, which is kind of a normal state in lots and lots of clients.
Sadly, yes.
And I don't want tests that take too long. And in the end, I also want to know not just the requirements have been implemented, but how much of the code did it cover? And we actually, I did this for fun the other day. I was doing some research on code coverage, and I asked a couple of the chat bots out there to get different answers, like how common is it for people to release software with a very low level of code coverage? And the answer from both these engines was it's like 30% that people typically have when they release, meaning that 2/3 of the applications never are tested, or at least not in a meaningful way. So measure what you're doing, right? You can't control it.
Right. I agree. It's I like the point where you're talking about that the test and the failure has to be meaningful, because I know a lot of the times I've been on tests where you're writing tests for everything, another fuzz test on an input, and you're like, okay, this is good, I should know this, but should this be run every single time? If this fails, gravity stopped working. At this point, if it's this deep into the process and I've gotten something wrong, it's you want to be able to craft your tests almost like I've looked at it this way. You're writing an application, you're writing a testing application on top of your application. It's got to be, and you've got to think about that as a separate project almost. That has to be, like you're saying, it has to be performant. It has to have meaning. A test for test's sake isn't really helping anyone. And then when it fails and nobody does anything about it and you still launch anyway, you didn't do much. You're
One of my favorite silly answers from testers when I ask them, so how good is your test suite? right? If it's going to be continuous and it's going to be tied to a binary decision of go,
Right.
no go, like how good is the test suite? How confident are you in it? Oh, well, I have 30,000 tests. I go, I don't know if that's too many or too few.
Right.
It's not there's no way that quantity alone is a meaningful number.
Right. You have to measure it. You have to treat it like its own project.
Yeah, and ultimately it may take a while to get there, but you do want a binary decision ultimately that the machine can drive. Yeah, that is the dream of continuous, right? That the system can approve the software in a way that you're comfortable with,
right?
And then hopefully go on and deploy it, like we see lots of organizations doing. And that implies that the test suite can give a binary answer, which implies that the tests inside of it are giving a high quality binary answer. And maybe some of them are giving a severity that you go, if this fails, it's a Sev 3 or a Sev 5. It's something we can live with. If this fails, it's the end of the world.
Right.
And you need to stop the bus right now. So that's that thing you don't think about when you first automate. You're just like, let me get it to run without intervention, but then let me get a meaningful answer, then get me a quantifiable meaning answer. Because if you and I look at a test suite and there's, 500 failures, we do a scan, we're looking for critical things, and we're deciding yes, no. How do we get the computer there? The other thing that comes up, of course, is that when you're changing functionality, the test can be failing, but what it really means is the test is out of date. And that's one of those areas where I think today the interesting usage of AI as we start to see auto remediation and self-healing driven by AI and LLM, right? It's a fascinating area because now we can be even more confident in our test suites and we can make them bigger and still manage to maintain them.
That is a great segue for our upcoming episodes. So I think we'll cut it here today. And I'd like to thank our guest, Arthur, and for this insightful discussion. And I want to thank, of course, our listeners and viewers for tuning in. We're going to on our next episode, we're going to talk about AI test generation and trying to get to that sweet spot that we were just discussing. And as we continue our quest to solve for X in the SDLC equation.
Thanks so much, Michael.